Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this video, we're going to talk about transformations of functions. Let's get started. Before we go into a study of the transformations of functions, it is important to have some general idea of the parent functions, at least some of the basic parent functions. And what I mean by that is, I've identified some 12 basic functions. This is the linear function, all right? So these are the parent functions, and parent functions are the ones that get transformed. So the linear function, the parent linear function is y is equal to x, or f of x is equal to x. And this is our famous quadratic function. The quadratic function, the parent function is y equals x squared. Just to know the shape of the graph, but not just to know the shape of the graph, it is also important to know something about the domain and the range. Some other features of the parent function is important to know. And for the purpose of this video, we'll keep our eyes on the parent quadratic function and try and study the transformations based on the parent function. You could have done that with any of the parent functions, but like I said, once you have identified the parent function, try and note down the domain and range and some of the features, like, what are the end behaviors, maybe the vertex, if this is in the case of the quadratic, some of the key points. These are not critical points like the stationary points, but some of the key points that you would like to see how it has transformed from the parent function. Okay, so that being said, let's just jump to our calculator. This is my parent quadratic function, and as you can see that the vertex is 0, 0. All right. This is a nice simulation on the calculator where you can actually move this point and just watch what will happen when I move the vertex. And that's what I meant by saying that if you have the parent function and if you've identified some of the key features, now this is the parent quadratic function and the vertex is what's identified as 0, 0. Watch what's going to happen to the equation. The equation is here, the equation of the parent quadratic function y equals x squared. Just keep an eye on that and keep an eye on the vertex, okay? Let's see if we want to move the vertex up. We want to move the vertex up, okay? Keep an eye on the equation and keep an eye on the quadratic curve. So when I move it up by 1 unit, can you see what has happened to the equation? X squared plus 1. Move it up, and the vertex has changed to 0, 1, okay? It was 0, 0. Let's do that again. See, it's 0, 0. You moved up by 1. The vertex has now become 0, 1. So, and the equation also has become y equals x squared was the parent function. It's become y equals x squared plus 1. In the same way, if you move it up one step further up, it becomes, the vertex becomes 0, 2. And the equation of the quadratic is now y equals x squared plus 2. And that is a nice way to study the transformation of the parent function. The parent function was y equals x squared seated at the origin. The vertex is at the origin. But now when you move the vertex up by 2 units, the equation becomes x squared plus 2, and the parent function has moved up by 2 units. That transformation is what we call a translation. It's translating vertically up by 2 units, okay? And in the same way, if it was to go down, if this is my vertex at 0, 0, the parent function, if the vertex goes down, translating vertically down, you can see that it is 0, negative 1, and the equation becomes y equals x squared minus 1. And so if you were to make a note of this and say that the translation is our transformation. Translation is just a shift, okay? And we're talking about a shift, vertical shift here for the parent function. So if I say vertical shift, okay, I can generalize the observation that we just saw on the calculator and say that the parent function, when the parent function is y equals x squared, the parent function becomes something like this, y equals x squared plus k. We observe something like this, that when k is positive, when k is a positive number, we have a vertical shift upwards. Vertically shift upwards. Making sure that you can see this. And then when you have k as a negative number, you'll have a vertical shift downwards. Right? So if the parent function is y equals x squared, you have a y equals x squared plus k. The transformation is translation, and that k is talking about a vertical shift. If the k is positive, it's a vertical shift up. If k is negative, it's a vertical shift down. So coming back to our graph, let's verify that again, all right? So if I had the vertex moving down by 2 units, as you can see, it's x squared minus 2. And so when you see the equation y equals x square minus 2, that's a shift, that's a translation of the parent function y equals x square by 2 units down. Now, let's look at what happens when we move this vertex horizontally, right? So let's bring it back to the original position. So now the parent quadratic has its vertex 0, 0 at the origin, okay? So now let's try and move the vertex horizontally. Notice what's happening to the equation, all right? Keep your eyes on the equation y equals x square. So when I move the vertex to the right by 1 unit, see the vertex becomes 1 comma 0, all right? But take a look at the equation. It's x minus 1 the whole square. X minus 1 the whole square. Earlier when we moved up, it was x square plus 1 or minus 1. Going up was plus 1. Going down was minus 1. And this is kind of strange because normally you'd think going right should be positive, all right? So just keep an eye on when it goes left by 1 unit. X plus 1 the whole square. All right, the same way when I go to the right by 2 units, that's 2 comma 0. And here we have x minus 2 the whole square, which means that if I were going left by 2 units, it would become x plus 2 the whole square. And that can sometimes throw students off because, hey, going left is positive, going right is negative. But for now, just hold on to that, okay? As confusing as it might be. In some other video later on, we'll explain when we're talking only about quadratics, why is it so? It has to do something with the roots. So when we talk about the roots of a quadratic, we'll understand clearly why is it x minus 2 when the quadratic is shifting to the horizontally to the right, and why is it x plus 2 when the quadratic is shifting horizontally to the left, okay? But what we need to understand right now is that when the parent function has its vertex 0, 0, y equals x square is the equation of the parent function. But the moment it goes to the right by 1 unit, it's x minus 1 the whole square. When it's going to the left by 1 unit, it's x plus 1 the whole square. So let's make a note of that quickly on our notes. And we can say that that vertical shift, as we saw, now when we talk about a horizontal shift, okay, the form y equals x square of our parent function, y equals x square of a parent function becomes or changes or transforms to y is equal to x minus h the whole square, okay? I'm going to use this h here right now, x minus h the whole square. And you got to be careful with this thing, all right, because of that positive negative. When h is positive, remember h is positive means you're going to get x minus a positive number, right? So when h is positive, it's going to be a horizontal shift to the right. H is positive means you're talking about a number like, let's say h is 3, then this would be something like x minus 3 the whole square, okay? That means it's going to the right by 3 units. In the same way, when I have h is negative, it's going to go horizontally, a horizontal shift to the left, okay? In the same way, if you take h as a negative number, let's say h equals negative 2, all right? If h is negative 2, you'd have the equation something like y is equal to x minus of minus 2, is that right? X minus of minus 2 the whole square, all right? And that would make it x plus 2 the whole square, all right? So this is what you'd probably see when it's finally simplified, but that actually means that the value of h is negative, all right? And so h being positive, it's a translation to the right. H being negative, it's a translation to the left. So we have seen translation, both vertical translation and horizontal translation, vertical shift and horizontal shift. In the vertical shift, it was y equals x squared plus k. Notice that k was outside of that parent x square, okay, x squared plus k. So it's either a plus k or a minus k, or a plus 3 or a minus 3, okay, the k being positive or negative. But when it comes to a horizontal shift, that number, whether it's plus 3 or minus 3, it's within that x square, okay? So it's affecting the x and not the y. It's affecting the horizontal and not the vertical. If we were to combine them, if we were to combine this transformation, if we were to combine it as y equals, let's say, x minus 3, the whole square, plus a 2. Combining the two, can you see that combination? Y equals x minus 3, the whole square, plus a 2. What does that mean? Okay, this is what's h. H is positive, okay? Just remember our form is x minus h the whole square. Okay, keep that in mind. X minus h the whole square. So when you compare this, h is 3, and then we have that as a k, all right? So our equation is x minus h the whole square plus k. K corresponds to 2, and h corresponds to 3. it means our quadratic x minus 3 the whole square plus 2 must move to the right by 3 units and moves up by 2 units. Let's just check it and confirm it on our calculator. Look at the equation x minus 3 the whole square plus 2. The quadratic, the parent function has gone from the origin 3 units to the right, 2 units up. And that hk, 3 and 2 are the coordinates of the new vertex. The parent function was 0, 0 and the new vertex is now 3, 2. Let's bring the quadratic back to its original position. That means the parent function, there's the 0, 0, the vertex, okay? Now let's see how the equation changes. That's the parent function, right? How the parent function changes when the vertex moves to the third quadrant, somewhere in the third quadrant where both are negative. The h is also negative, k is also negative, all right? So watch now, it's 0, 0. Let's just take it somewhere where it is negative 1, negative 3, all right? So h is negative 1 and k is negative 3. H is negative, and remember, if h is negative, the quadratic moves to the left, and you can see that it's moved to the left, right? And k is negative 3, you can see that the quadratic is moved below, vertically down. And the equation, notice the equation, that x plus 1, yes, it can put you off, but remember, h is negative, all right? X plus 1 the whole square, but h is negative because our form is x minus h the whole square. So negative 1, negative 3, again giving you the coordinates right from the equation, x minus h the whole square minus k, all right? That's minus k, that k is negative 3, all right? So when we make a note of it again, okay, for the second case which we had h as, can you guys see this? Negative 1 and k as a negative 3. What happened, all right? Remember the equation was x minus h the whole square, y is equal to x minus h the whole square plus a k. That was our equation, right? So what happened is h is negative 1 and k is negative 3. So we have the equation as x minus of minus 1 the whole square, and k is a negative, I'll just make that this way so that it becomes easy to understand, all right? Now when you simplify, you'll get it as x plus 1 the whole square and a minus 3, and that is exactly x plus 1 the whole square. That's exactly what we saw here, right? X plus 1 the whole square minus 3. And the same thing is what we got here when we wrote it down. So this equation that we have here, x minus h the whole square plus k, becomes an equation to reckon with. This is an important form of the equation of the quadratic because this is also sometimes referred to as the vertex form. Okay, for a couple of reasons this is important. When we do a video on quadratics, we'll go through it in more detail, but this is called the vertex form because just from the equation, algebraic equation, x minus h the whole square plus k in this vertex form, the algebraic process is called completing the square from the standard form to right to the vertex form. But once you get these numbers h and k, you know that they are the coordinates of the vertex. The vertex is the turning point, as we saw. But this vertex form of the quadratic also gives us an idea of the translation, okay, from the parent function y equals x square. How has it translated? If the h is positive, then the quadratic has moved to the right. If h is negative, the quadratic is moved to the left. If k is positive, the quadratic moves up. If k is negative, the quadratic moves down. So this equation y equals x minus h the whole square plus k gives us an idea of the translation of the parent function. The parent function being the quadratic, we chose the quadratic. You could have used even any other function to try and do this kind of an experiment to find out what is the translation, vertical translation, what is the horizontal translation. Let's say, for instance, you want to do something with absolute value function. The absolute value function y equals the absolute value of x, and you could use the same idea of x minus h plus k, and you know what, it's going to have the same effect. All right, that's again a translation, h giving you the translation horizontally and k giving you the translation vertically. So say for instance you had x plus 4 and minus 3. All right, now we said that when h is positive it's going to go right, and negative when it's going left. This is a negative h because as you can see this is x minus of a minus 4, all right, because it has to be in this form, x minus h, okay, and that's a minus 3. So it's going to go, the parent absolute value function is a v function, right, the v-shaped function that is, right? So it's going to go left by 4 units and it's going to go down by 3 units, okay? So let's just check that quickly before we wind up this video. I'm going to go and enter the parent function. That's my absolute value function, x. All right, there we go. That's the parent function. Now let's go and enter the second function as we wrote it down, x plus 4 inside the absolute value sign, and outside that is a minus 3. And remember what I said, it's going to go left by 4 units and down by 3 units. Okay, just take a look at it. There you go. And as you can see, the vertex, which is 0, 0 here, the parent function has now moved left 4 units and down by 3 units. And if you want to verify that also, you can go analyze that and figure out what the minimum value is. The red graph, there you go, -4 and -3. So I hope that this video was useful to you in understanding translations of functions. I'm going to see you all in the next video.